Here we have our power pipe. It's a drain water heat recovery pipe. It's on the main drain stack from our shower, and the cold water is fed in at the bottom, and it goes through these coil wraps around the drain water coming out of the shower, and then comes out here off to our water heater. And it takes heat out of the drain water and transfers it to the water coming into the house, or going into the hot water heater. And what I've done, because I wanted to know how much temperature was being transferred, how much heat was being transferred, and of course in a shower that's equal counterflow, so it is the same amount of water coming in as is going out. So what I've done is I've hooked up a couple of thermistors as temperature sensors and taped them to the pipes, to the input and the output of the power pipe, and hooked those up to an Arduino, and I have it measure the temperature of each one of those and then calculate the difference and remember the highest temperature. So on the little 7-segment display I've got a couple of decimal places, and I'm using those not as numeric decimal places but as mode indicators or display indicators to tell me which reading it's telling me. So when the left digit decimal place is on, that tells me what the temperature on the input water sensor is in Celsius. When the right decimal place is on, like that, it says it's 20 degrees Celsius on the output, which tells me that when none of them are on, it tells me that the temperature difference is 13 degrees, and when both of them are on, it tells me what the maximum temperature difference that it's seen since I turned it on. So right now, it's seeing 13 degrees Celsius temperature uplift in a normal shower scenario. I would say typically that's probably a little bit of a cool shower. Typically, I'm seeing a degree or two more than that in what I consider to be normal shower temperatures. A warm shower, but, not a hot shower. And there you have it. And it's clearly working. That 13 or 14 degrees is somewhere near the theoretical maximum for this power pipe model, which is a 3-inch diameter model. And I forget what the height is. I think it's 54 inches. But the bigger ones are more efficient, I'm told. But that's what we get out of this one. Still, that's a lot of energy that doesn't have to be put back into the incoming water by the water heater. So I'm pretty happy with that.